1.7. Solving investment portfolio problems. A portfolio is simply a collection of investments. Each one of these questions is like having 5 of the questions that we have been doing already smooshed into one question. I'm going to be doing 2 of these via video, and the other one will be filled out in the classroom OneNote for you to follow. So let's not waste any time, shall we? Example number 1. Phyllis started to build an investment portfolio at her retirement. She purchased a $700 Canada Savings Bond, or CSB, at the end of each year for 10 years. However, here's the tricky bit. The first 5 Canada Savings Bond earned a fixed rate of 3.75%, compounded annually. The next 5 earned a rate of 4.25% compounded annually. This is going to be tricky because we're going to have to think of the Canada Savings Bonds in 2 different chunks. And because in 2 different chunks, 3 different chunks. You'll see what I mean. What was the value of Phyllis's portfolio 10 years after she started to invest? Oh, and I forgot to read one. 3 years ago, she also purchased a $4,500 GIC that earned 6.25% compounded monthly. I know why I forgot that one, because that one's the easy one. So, A part, what is the value of the portfolio 10 years after she started to invest? And B, Phyllis found a savings account that earned 5.5% compounded semi-annually. She redeemed her portfolio and invested all the money into a savings account. Approximately, how long will it take her to double her money? Hint, let's use the rule of 72 because the question just says approximately. Okay, so let's think of, I just want to move off to the side here just to think about our GIC, our Canada Savings Bond here. This is the first one, this is the second one, this is the third one, this is the fourth one, and this is the 5th one. Okay, let's go all the way down to 10. This is the 6th one, this is the 7th one, this is the 8th one, this is the 9th one, and this is the 10th one. Now, the first 5, 1, 2, 3, 4, 5, these guys are going to get a, oh, that was a funny thing. There we go. They are going to get a 3.75% fixed rate. Yep. Whereas these ones, 1, 2, 3, 4, 5, these remaining 5 ones are going to get a 4.25%. So we need to think of this one right here, the first 5 as in 2 different chunks. Okay, this is the payment period, PMT, where the payments are $700 every year. And then this chunk right here, we have to say that we have to fill in what the present value is, okay? And then we have to let it sit for 5 more years at this interest rate. This guy right here, we're also going to say that the payment is $700. But there is kind of no sitting. Okay, but the interest rate is going to be a little bit different. It's going to be 4.25%. Because the interest rate changes, not for the initial investments, but for every investment or every Canada Savings Bond after the 5-year mark. That's why this one's a little bit more tricky. So let's fill in our charts here. So this is the first 5 Canada Savings Bonds in the payment phase. Okay, this is when we're actively paying into it. So we know that they're compounded annually and paid annually. We know the payment is negative $700, or the money that's going away is $700. The future value we don't know. We're going to figure that out. The present value is 0 because we don't start off with anything. Our interest rate is 3.75. And our number of years is 5 years times 1 compounding period per year. So when we bring up our TVM solver, oh hello, wake up, oh look at that, enter, this is the one. We want to go 5, I'm just going to copy what's in the here, 5, oh, zero is good there, negative 700. Future value, we don't know, we're going to come back to it. And payments per year and compounding periods per year is just 1. So alpha, enter to solve for your future value here. So we have 3,772. So $3,772.53. Now the next thing that we need to do is figure out that sitting chunk, okay? Because we're not at those five Canada Savings Bonds are not actually receiving any more money. They're just kind of sitting at that 3.75%. So we have done the first 5 Canada Savings Bond in that payment zone, and then the second 5 years, and this is just the compounding time. So we know that payments per year and compounding periods per year is 1. We're letting it sit for 5 more years at 1 compounding period per year. The interest rate is still the same, 3.75. Now here's the thing, we know the present value. The present value here is going to be $3,772.53. At this point it's just sitting, so we have no payments, and we want to figure out what that future value is. So let's do that, shall we? So I'm just going to move this guy over so we can see it. What do we need to change here? Yes, this is going to be, oh, actually, my bad. This should be negative because it's money initially going away. It's going to come back, but it's initially going away. Is everything else good? Let's see. Yep. Alpha, enter. What is our future value? $4,534.96. Okay, so that is for the first 5 Canada Savings Bonds that we purchased. What about the second batch of Canada Savings Bonds? Well, we're saying that it's still going to be $700 payment per year, but the only thing that changes here is the 3.75 changes to 4.25%, so our interest rate changes. So essentially I can copy this with one exception. This is 4.25. We're going to solve for our future value, compounding period per year, and payments per year, 1. So let's do this. So this is going to be 4.25, enter. This is going to be 0, because this is the second wave of the Canada Savings Bond at the new interest rate. Payments are $700, and because the money is initially going away, we need to put negative. And then you go alpha, enter. And there we go. We get $3,810 or $3,810.41. Whew! That was tricky with those Canada Savings Bonds. So these are the two things, if we're to consider our Canada Savings Bonds, just our Canada Savings Bonds together added these two things together. So let's focus on that GIC. I promise you this one's going to be easier. So this is the GIC. let's see, so 3 years ago, so it's for 3 years, she purchased a $4,500 GIC at 6.25 compounded monthly. No problem. We got this. So we're saying that it is 12 compounding periods per year. It is for 3 years, so 3 times 12 is 6.25, the interest rate. The present value, it's just one lump sum of $4,500. Payments are 0. It doesn't say that we put any additional payments into it, and we want to solve for future value. Let's do that, shall we? So this is going to be 3 times 12. Look at that, it just changes it to 36. So nice. I'm going to go back up to the future value because that's where we have our dot. I'm going to go alpha, enter. Oh, what happened there? Wait a minute. Look at what I put here. I said negative 450. It should be negative 4,500. No problem. Simple fix. Alpha, enter. There we go. That's what I'm talking about. So 5,420. What now? 2540. So if we want to figure out what our portfolio is, let's just get all of this into view. So A, the portfolio is going to be 38, 10, 41 plus 45, 3, 4, 96 plus 54, 25, 40. Altogether, that's going to be $13,770.77. We have to be aware that we're dealing in money here. So if I see this one rounded, say, to 0.8 with no dollar sign, that's problematic because we are working in the, in the actual realm here. This is something that we know what kind of decimal places we're dealing with. Now it says the approximate doubling time for an investment at 5.5%. No problem. We can just use the rule of 72. So we say 72 divided by 5.5, and it's going to be approximately 13.09 years. So it will take her approximately 13.09 years to be able, or just over 13 years, to be able to double her investment.